Another topic for the introduction to computer architecture and security is what we call the memory and storage. Memory is used to carry out arithmetic operations and store intermediate results. So there are two factors to the memory that affect a computer's speed the most: the size and the speed. More memory can result in less intermediate result storage and less operation, so therefore it improves computer speed. High-speed memory can reduce the delays during each operation. A complex problem requires a tremendous amount of computation, and thus the delay would be significant if a low-speed memory is used. Computer memory is organized into hierarchies. Registers are the fastest memory. They are specifically wired to guarantee the maximum speed. Cache memory is the next fastest memory. The idea behind using cache is to reduce the time for CPU to read or write data directly from the main memory, and this may cause a longer delay. Cache memory usually uses a static RAM or SRAM. This is accessed by blocks and is often divided into 2 to 3 levels. The main memory has much larger capacity to store application and data. It uses dynamic RAM or the DRAM, which is a type of memory that is cheaper and can be highly integrated, but with a little less speed than SRAM. Hard drives are external memory or storage that has a vast amount of capacity. The solid-state drive is a new type of storage that acts as a normal hard drive, but without mechanical movements, so they are more reliable and faster. With the advancement of technology, SSDs are becoming cheaper and more affordable. Take note that level 0 to level 2 are inboard memory, while level 3 are outboard storage. Level 4 are offline storage. Another component of the computer is the input-output and network interface. Computer systems typically have several I/O devices. The I/O interface is used to receive data in and write data out with devices such as a keyboard, a mouse, displays, and printers. Computers now are interconnected through network or internet. Most people check emails every day, if not every hours. Vast information can be found on the internet, so the network interface card has become an integral part of a computer system to handle data communication needs. There are different interfaces to connect the processor and the I/O devices. Many recent I/O devices are equipped with the USB or the Universal Serial Bus. The USB unifies the interfaces with its easy-to-use plug-and-play connectivity and hot plug characteristics. In addition, the speed of USB is considerably high so that it can support most I/O devices. The new super-speed USB 3.0 has a faster speed of 5 gigabits per second. I/O security is also related to data security. Data stored on hard drives may be exposed to attackers, especially insider attackers. Encrypting all data on hard drives is one solution, but it may result in performance issues. USB storage devices can be used as bootable devices to start a computer. Unauthorized uses can let attackers steal data on computer system. In places where data security is a concern, the USB port should be disabled. So traditionally, computers contain one central processing unit. It is like a human brain that controls all activities and remembers all things around it. To solve a problem, an algorithm is programmed and executed as a serial stream in instructions. Only one instruction may execute at a time. A multiple CPU, on the other hand, can process a computer can process a computation task simultaneously by breaking the problems into independent parts. Each CPU can execute a portion of the problem. So such a procedure is what we call a parallel programming. Parallel processing system contains multiple CPUs that are interconnected or manufactured together as multi-core processors. So we can compare the CPU to a human brain. So this is the structure of a typical neurons. So the single core processor versus the multi-core processor is shown in the figure. A single core processor is a typical structure of the CPU. It processes data simultaneously as long as the operations are not too complicated. For a multi-core processor, parallel processing can be done without sacrificing the speed of the CPU. Since it uses two or more processors with individual memory to store and process data independently with each other. The processed data is connected to a shared memory. One or more computers are multi-core processors, where each core is acting like an independent processor. The architecture of the multi-core processors can be organized as each core contains a CPU and a level 1 cache. A bus interface connects all cores and also provides a level 2 cache. All cores and interfaces are interconnected on one circuit or one die. Most parallel processing computers uses multiple processors or an array of processors to form a supercomputer. The processors can be at a centralized location or they can be at distributed location. Distributed computing has tremendous power to accomplish jobs which otherwise would not be performed with traditional computers. Examples of these computers are the pharmaceutical computer companies, which uses hundreds of thousands of computers distributed across the country to simulate clinical tests. It can greatly shorten the time for a new drug test. Sophisticated computer hackers can also benefit from using the distributed computing platform. They are able to shut down Visa or MasterCard companies' website and other government websites. They launch so-called a distributed denial of service attack or the DDoS attack. In a typical DDoS attack, the army of the attacker consists of the master zombies and the slave zombies. The hosts of both categories are compromised machines that have arisen during the scanning process and are infected by malicious code. The attacker coordinates and orders master zombies, and they, in turn, coordinate and trigger slave zombies. More specifically, the attacker sends an attack command to master zombies and activates all attack process on those machines, which are in hibernation, waiting for the appropriate command to wake up and start attacking. And then, the master zombies, through these processes, send attack commands to slave zombies, ordering them to mount the DDoS attack against the victim. In that way, the agent machines or the slave zombies will begin to send a large volume of packets to the victim, flooding its system with useless loads and exhausting its resources. Most DDoS attackers are designed to consume all available network bandwidth and resources on a target network, system, or website. The attackers uses one of many available methods and tools to flood the target with a barrage of malicious and nuisance requests, or to abuse a protocol or inherent vulnerability in such a way that the system can no longer respond to requests. The effects of DDoS attack are a bit like having the entrance to a concert venue suddenly swarmed by a busload of troublemakers with counterfeit tickets. The legitimate ticket holders standing in an orderly line would never get inside.